Hello guys, this is Prime Concept. Now we have another problem under capacitors to analyze. So do well to watch my first video on that capacitors so that you can get the concept behind capacitors. And if you have been following my channel, do well to hit the subscribe button so that you can be the first to be notified whenever I post new videos. Try to like my video so that it can get to more audience. So, share with your friends so that they can also benefit. Now let's solve the problem we have. We have a 5.8 microfarad capacitor. So the capacitance is 5.8 microfarad. So I would simply say times 10 to the power minus 6 farad. So that's my capacitance. Parallel plate capacitor has a plate separation. So the distance between the plates is D equals 5 millimeter. But you know you need to divide this by 1000 to get the value in meters. So we have 0.005 meters and is charged to a potential difference of 400 volts. So the potential difference V is 400 volts. And the first question says calculate the total energy of the system. Now we know that to find energy, potential energy of a capacitor, so it's going to be half CV squared. So we have that the potential energy is half times C, which is 5.8 times 10 to the power minus 6, and V is 400 squared. So if we solve this, we're going to have, let me quickly punch this, 5.8 times 400 times 400, okay, divided by this. So I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I have 4.64 times 10 to the power minus 1, or which I can just simply say 0.464 joules. So this is my answer, right? So this is the first question we have to answer. Now the second part of the question says that we should calculate the energy density in the region between the plates of the capacitor in joule per meter cube. And you recall from one of my videos I explained energy density. So energy density is denoted with small letter U and a subscript D. To show its energy density is half epsilon naught E squared. So this is the formula for energy density, where we know that epsilon naught has a value of 8.85 times 10 to the power minus 12 farad per meter, and then E is electric field. We know that electric field E is potential difference divided by distance of separation. So our potential difference in this case is 400 divided by our distance 0.005. So if I divide this, I will have 400 by 0.005. This would give me 1, 2, 3, 4. So this would give me 8. So this is 80,000 volts per meter. Now I want to now find my energy density. My energy density is half times epsilon naught, 8.85 times 10 to the power minus 12 times E is 80,000 all squared, right? Now if I punch this, I would have 8.85 then divided by 2. So I have, this is 1, 2, 3, 4, 5. So this is 3.54 times 10 to the power 5 minus 12 is minus 7, right? So this is what I have joule per meter cube. So this is the value for my energy density, and I believe that the concept is very clear. So if you have watched this video up till the end, please do well to hit the subscribe button, like the videos, and share with your friends so that they can also benefit. Remember, this is Prime Concept. Thank you.